Real-world sustainability using BIM tools. My name is Lucy Wood, and I am an architect working at David Miller Architects. The following presentation was prepared for EcoBuild 2013 to comment on the subject of real-world sustainability using BIM tools. To do this, we will introduce and then explain with case studies the sustainability strategies embedded into our workflow at DMA. We are a small architects practice based in central London. The majority of our work is in zones 1 and 2. We have completed a number of projects in education, housing and mixed-use sectors over the last few years, and more recently have been working on some exciting community and regeneration projects. We have been working exclusively in BIM for the past 3 years, so rather than giving an introduction into BIM, this presentation explains how we are using it to achieve our sustainability goals. We have developed this diagram to illustrate the practice's sustainability strategy. The outer ring describes the practice's core aims, broken into 4 parts: social sustainability, lean design processes, intelligent specifying, and efficient operations. Each of these are aligned to different stages of the new 2013 RIBA Plan of Work, which is shown in the inner ring. Most importantly, each core aim feeds into the next, encouraging an ongoing sustainable approach throughout a project's life cycle, and encourages one project to inform the next project in a circular workflow. With each stage, we simply add information to the model, refining details as we move through the life cycle of the project. I will now discuss 3 of the practice's recent projects. Each illustrates how the practice's core sustainability aims are put into practice using BIM tools. We will cover how clients and stakeholders interface with the model at feasibility and at post-occupancy stages, how we as architects interface with the model at concept design stage, and how the design team as a whole interfaces with the model at technical design stage. To begin with being socially sustainable. At preparation stage, BIM tools allow us to deliver detailed feasibility studies in the often tight timeframes required by our clients. Communicating proposals 3-dimensionally at these early stages is very useful on commercial projects where clients are looking for rapid validation of proposals. The proposals can be clearly communicated, reducing the risk of misunderstandings, and the interface between the proposals and their surroundings can be managed. We were commissioned by City West Homes to investigate the feasibility of redeveloping these 2 sites of Lisson Grove in West London. On one site, to provide 7,000 square metres of primary care trust space and 50 residential units, and on the other, to investigate how best to maximise the site's potential redevelopment. To begin, we took the 2-dimensional master plan data, which outlined the aims and objectives for the regeneration of the site, and translated this into 3-dimensional data to analyse the issues of the existing development. This 3-dimensional analysis of the site highlighted the current poor street presence along Lisson Grove and areas of unoccupied site footprint that were encouraging antisocial behaviour. Early 3D information is also used for daylight and sunlight analysis. This allows us to fully understand the impact of our proposals on neighbouring buildings and informs our subsequent design proposals. There was no need for consultants to build their own models of our proposals, which sped up the production of the 3D jelly mould envelope shown here for us to respond to, hence speeding up the overall project workflow. We also use output from the model to create stakeholder-friendly graphics. These are very good for communicating with people who can't easily read 2D drawings, and allows our clients and stakeholders to make informed decisions earlier in the design process. These drawings do not have the formality or finality of a fully rendered image, and stakeholders seem happier to engage with proposals in this format, leading to more comprehensive comments on designs. Floor plans and schedules are generated as a byproduct of placing the simple geometric volumes. This allows us to accurately and numerically assess options against one another and communicate these findings to our clients. To move on to lean design processes. It is widely recognized that 80% of the operation, maintenance, and repair costs of a building are fixed in the first 20% of the design process. Rapid energy modeling is one example of being able to optimize the sustainability of a design in-house from its very earliest stages. BIM tools allow us to carry out this very early stage thermal analysis and feed these findings back into the initial massing proposals, even before consultants are on board. This project was for a 24-story hotel on a very sensitive site in London. Here, all the buildings shown in pink are unbuilt projects, which have planning approval. Massing the proposal surrounded by its future, immediate and wider context was used to future-proof sustainability strategies. It was also a very persuasive tool for planning discussions. Energy performance was analysed by running simulations within Revit. Project-specific parameters were added, such as building type, building location, and HVAC specification. The resulting reports provided a real-time preview of how various design decisions were affecting life cycle performance. For example, annual carbon emissions and energy consumption. In short, BIM tools allowed us to fine-tune the building in sustainability terms at the very early stages of the design process, avoiding costly changes post-planning. The third case study explains the benefits of intelligent specifying. The power of having a BIM does not just lie in the benefits of a 3D model, but also with the information that is generated by that model, such as product quantities and area takeoffs. In addition to this, the model can be further enhanced by adding product-specific data to model components, which can then be extracted as and when required. This mixed-use project in Barking, London, comprises a large supermarket, 100 residential apartments, and 5 retail units. The residential apartments are targeting Code for Sustainable Homes Level 4, and the whole development is projected to achieve BREEAM Excellent. On this project, the structural and MEP models have been integrated with the architectural model to aid coordination and clash detection. Now here is an example to show how we add data to the model for real-world gain. In this example, in order to provide evidence required for BREEAM credit MAT 6 insulation. Typically, insulation wouldn't be modeled as a single component, but would be part of a wall, roof, or floor build-up. However, for this example, we will focus on the soffit insulation required in the project's basement. The workflow begins by adding the soffit into the model, in this instance as a generic ceiling type that sits on the underside of the ground floor slab. As we develop the model, we swap out and update the properties of this placeholder object, replacing it with a data-rich, manufacturer-specific component, which has been downloaded from the NBS National BIM Library. One of the many benefits of using these objects is that key performance data is already embedded into the component, reducing the workload of having to find and coordinate information from different sources. You can see the object contains properties such as thermal resistance and green guide rating, for example. This information is quantifiable and accurate, and can be scheduled easily to form part of our BIM evidence. Onto floor plans, into schedules, and ready to upload for review. And finally, we take a brief look at the fourth stage of our sustainability strategy, efficient operations. What happens when the project is complete? This is an area that, as a practice, we are pushing to explore further and believe there are three key topics that we need to focus on. Firstly, how we can gather data sets and building performance data at the end of a project to feed into the concept design stage of future projects. Secondly, how we can embed FM data into the model and then extract this for the production of COBie spreadsheets and O&M models. And finally, how we can learn from post-occupancy evaluations and how we can feed this into the briefing stages of future projects, employing initiatives such as the government's Soft Landings programme. We hope this presentation has provided a useful insight into how, as an architectural practice, we are tackling sustainability using BIM tools.